Well, thanks everybody. Thanks for attending and inviting me to speak, Eric. And I think I'm the fourth in a series of a number of these webinars that you're putting on, which are great. I'm looking in the participants screen, and there's a lot of familiar names. So for those who have kind of been on this journey with me and together for the last a couple of decades on looking at trash and trying to address the impacts and the sources as time has played out. And so I've, as Eric said, been working on this for, dating myself now, but at least about 20 years. And way back when the first studies were conducted in LA and in the Bay Area on looking at the levels of trash in local waterways. And then I've kind of witnessed the education and the public involvement and engagement of this issue as it's transformed into becoming more aware, people becoming more aware of this issue, and then also more awareness and I'm excited for your September webinar on microplastics, which is something that, it's kind of transformed into not just the macro plastics that we've been and trash that we've been talking about, and I'll focus my talk on, but now the scientific community and the public are definitely interested in the subject matter as well, as it relates to both macro and micro trash. So today I'm going to try to tell a bit of a story, I guess, of some background on how this all started, this interest in impacts on waterways related to trash, and then response from the regulatory side of things, and how it's moved into implementation, how that's based on the science that's been done, and how we're trying to monitor and assess how well we're doing over time in response to the regulatory policies that have been put in place and continuing to evolve over time. So my talk, here's kind of a presentation outline of my talk. I'm gonna talk a little bit about some contextual background information, but it's super important on kind of how we got here, and in particular talking about sources and pathways, which is an important concept when we look at the regulations and the control measure implementation as well. And then give you some examples of what's being done on the stormwater side of things by local municipalities, and trying to address the regulations and also improve the levels of trash that are being transported through the storm drain system. And then I'm going to touch briefly at the end of kind of how we're measuring, or one way we're measuring progress. I get asked this question a lot, and I think we all do, who have been in this world for a while, is, what is trash? It's actually defined by the government code as litter, and it really just covers anything that is improperly discarded or thrown into the lands or the waters of the state. To give you a little bit of context, we did some research on just how much waste is actually produced in California each year, and it turns out on average it's about 38 million tons of consumer items and waste materials, and that equates to about a ton of material, solid waste, that each resident in California generates every year. And so if you think about it in those terms, a ton of waste that each of us generates every year on average, some of that material is going to escape and get into the environment. That is what we're in essence dealing with, is what has gotten into the environment and is being transported to our local waterways in some fashion. When we look back in time about what kind of documentation of the increasing impacts were occurring, it really began in the early 90s through a lot of work in Los Angeles region and the San Francisco Bay region. Folks like Charles Moore down in LA and regional board staff like Steve Moore, who was a former state board member, started looking at trash levels within our local waterways and rivers and creeks and on beaches. And this was kind of more quantitatively understanding this from a scientific standpoint. And we're finding that there's alarmingly high levels that were associated with those waterways. And then, that then was compared to the impacts that were starting to be documented about trash entanglement, ingestion that was happening to wildlife, the impacts to recreational activities, and then potentially even navigation when you get in navigable channels and waterways. And so all of that work started to formulate the foundation and the need for additional actions and additional science as well. At the same time, and really for many years prior to that, one of the major efforts that the number one volunteer activity internationally that happens every year is Coastal Cleanup Day in September. And when you looked at the data that was being collected just on a pure number of items, and obviously there's a lot of different ways to look at data, but the numbers were increasing all the way from, here from 1988 all the way through 2017. And you can look at this many different ways, but every way you look at it, the numbers of the amounts of trash that we were finding in waterways continues to increase over time. And it's not coincidental. I wouldn't suggest it's coincidental that the amount of trash that we're finding in coastal cleanup days is increasing at the same rate or similar rates and timeframes that our use of single-use plastic materials is also increasing as well. And I'll show you some slides later about why that's an important concept, because one of the major things we find in waterways are single-use plastic, mostly food-related materials and items. And so kind of pictures are worth 1,000 words here. Coyote Creek on the left, and this is in the early 2000s in the portion of Coyote Creek in San Jose, and then the LA River at the Boom site in the downstream portion of LA River, and just the vast majority of what we're finding here is plastic or some form of plastic, and as I said, mostly single-use plastic materials. And these are similar to photos you would see in other countries where we see on the news, and this is our state of California and waterways that are here. So our goal is to improve this, right, at the end of the day, and that's what the regulations and that's what the implementation actions that are being implemented by local municipalities and others are trying to do. The goal here is to not have to clean up this out of waterways, but rather to try to reduce it prior to reaching these waterways. So it's an important, I know people like to gloss over this sometimes, but from a practical management standpoint, it's really, and that's at the statewide level, at the local level, even at the watershed or at the site level. It's very important that we understand at the end of the day, where is this trash coming from? What are the sources, and how is it transported to the places where we find it in waterways? And it's important really for two reasons. One, it helps actually construct control and implementation actions. I like to use the analogy that if we're finding that inadequate waste container management is a big source because of the lack of maintenance or the lack of trash cans, public trash cans within a commercial area, I wouldn't necessarily suggest a completely different type of control measure that's not directed at that source. I would suggest a control measure that is trying to address the source that we're identifying, in this case, an inadequate waste management program. I could list other sources here, and some argue that sources include the generation or production of certain materials as well. And it's a fair point, and it's important as a control measure as well, which we'll talk about a little bit later, about true source controls that could help these efforts as well. When you get into pathways, when you're physically in a waterway and looking at trash or picking up trash and trying to quantify it, you have to ask yourself where it's coming from. How is it transported to this place? Is it someone who is visiting that site and literally littering at that site? Is it someone who's living at that site through encampments that are there? Or is it actually transported through the pipe system that eventually gets to the site where we're seeing the trash? And the reason that's important is because, one, regulations deal with these different pathways differently. And two, again, it tries to put context to how well actions that are focused on these different pathways are performing over time. Are they making a difference? And so when we look at it as a study that was recently conducted in the Bay Area, this was a study of trying to test out new methods that looked at identifying pathways based on some specific characteristics of the types of trash we were observing within waterways. And some of these new methods are included in, I saw Shelley Moore is a participant today. She's one of the authors, and I think that Tony Hale from SFEI and Shelley presented Eric at the last or a couple webinars ago on the trash monitoring methods playbook that just recently came out. One of those methods is the method we used in the Bay Area to conduct this study, and it was done at 820 monitoring events at 229 sites. 129 of those sites were randomly selected creek and channel and river sites around the Bay Area, and then 100 of those sites of the 229 were targeted at hotspots where we knew trash had been accumulating in the past. So our conclusions through this were that, one, it's very difficult when you're in the waterway itself to figure out which of those pathways that trash has come from. We do have some general indicators of the cleanliness of the trash, of new deposits versus dirtier looking trash that maybe had been there and traveled far distances. Also indicators of whether or not trash is associated with illegal dumping through bags and like construction material versus transportable trash that might come down through the storm drain system. But using these methodologies, the two graphs you see on the right-hand side at the randomly selected, which is considered ambient or probabilistic sites, you could see that, less than half of the trash that was seen there by the observers or the field work, the field crews, was associated with the stormwater transport process. And many of the other pathways were equally as contributors to this, to the trash that's being seen there. And when you get to the targeted sites, these are the kind of known hotspots, that number becomes even greater, where people who are visiting those sites and depositing directly, and also direct dumping increases, as well as encampments, which is unfortunately a big issue in the Bay Area around encampments around waterways. And so my point in showing this is that it's important to think about this when we talk about regulation and when we talk about expectations for those regulations to have an impact to what we're seeing in waterways. And I want to show I'll talk about the regulations here in just a second, but if you look at kind of the three main pathways of in-creek dumping at the top here, wind in the middle of adjacent properties and wind blown into the waterways themselves. And then also the storm drain system, the piped network that comes from the storm drains off the streets that drains into the local waterways. I'm really going to focus on this, the one at the bottom here today when I talk about it. The regulations, as we'll talk about, are trying to deal with all of these pathways, but the focus of the regulations to date have really been on the storm drain system and the stormwater permits that we'll talk about. So the regulatory responses really started out of the LA region and then soon after at the San Francisco Bay region. And many on the call have been addressing these regulations and have firsthand knowledge of the challenges of doing so. But there are many waterways throughout the state of California. The regulations themselves were either TMDLs or in the Bay Area, we went straight to stormwater permitting as the vehicle to try to address this issue. And again, that pathway of stormwater contribution to waterways. The goals that were set in the LA region were zero trash and stormwater discharges. And they gave the option of really doing trash full capture systems as the primary mechanism to get to that zero trash. And I'll talk about that term full capture here in just a second. And in the Bay Area, it took a little bit of a different approach where they built on what the LA region had done, but they also allowed for equivalency, which we see in the trash amendments, which were adopted back in 2015 as a statewide trash policy was implemented by the State Water Board. And that policy has three pieces. Just to remind everybody, it has a narrative water quality objective that is applicable at the statewide level, which basically says no trash in adverse amounts in waterways or surface waters. Second, there's a discharge prohibition for all trash discharges, and I want to stress on that, all trash discharges, not just from stormwater, but from all sources. And it basically says no trash and discharges in waterways. And then lastly, there is kind of implementation expectations or guidance and requirements that eventually would go into MPDS stormwater permits. And those focus on stormwater and the stormwater pathway. There seem to be alternatives to TMDLs, which many waterways in the state could probably go down the path of TMDLs, and the state board, I think rightly so, saw that was maybe going to be a super big challenge to develop those, and they wanted consistency, so that's why the statewide policy was developed and were developed. The state policy also requires that stormwater dischargers achieve the discharge prohibition by at the latest 2030. And so that is the backdrop now of when these goals need to be achieved. And there's two compliance pathways. I'm going to go through those really quickly and give you some examples of what's actually being implemented. So the compliance pathway, number one, and Leo Costantini from the state board, I think, was your first webinar presenter, so he probably went through this as well, but for the sake of those who are on the webinar today, the stormwater track one trash full capture system pathway is basically a treatment control or series of treatment controls that trap all particles that are 5 millimeters or greater, and that has a design treatment, it's important, a design treatment capacity that is not less than the peak flow rate resulting from the 1 year, 1 hour storm. So I want to make sure everyone's clear, and I think all those who probably on the call are clear. We call these full capture systems, but in essence, they are a design standards trash capture system that has a flow rate and a design that it treats for. Anything greater than that design or rainfall that occurs that is above that design, these devices have overflow devices to prevent flooding. And so they were developed, this design standard is developed out of the LA region and by LA County and studies that they did down there of determining what screening capacity these devices could have, and at what flow rates and design storms they could treat that size of trash of 5 millimeters or greater without flooding occurring within the systems themselves. And so this is the standard that has been set if you choose track 1. What the state board has done is they've created 3 categories of systems, and then now they certify the systems through a certification process that they run for vendors and those who are who'd like to have their devices put on a certified list. And there's criteria that they have to develop and have to achieve. Here's some of the criteria here and the aspects of that design standards and information that have to be submitted to the state board for certification. And about between 40 and 50 devices at this point that have been certified by the state board. There's a website here at the bottom. I think that link is live that you should be able to, or Google it, and you should be able to find the design information and the devices that have been certified to date. There, as I'll show you later, probably between 75,000 and 100,000 of these devices have been implemented statewide to date. Many of those in the LA region. I'm going to go through a few of the examples. I think I saw the question come through about how was the 5 millimeter standard developed. It was developed based on basically a screening size, and that screening size was 5 millimeters, was roughly the size of a diameter of a cigarette butt, and so they wanted to be sure that they got down to that level. Anything less than that size was going to cause clogging of the screen itself at a very high rate, and then the device itself would overflow and wouldn't provide much treatment. And so 5 millimeters was decided as the size at which flows could continue to come through that screen and not cause overflowing or treatment or bypass to occur. I'm going to try to pay attention to the chat as best I can as we go along. So I'm going to show you some examples and some imagery of the types of devices that have been implemented in many areas throughout the state. There's a couple different kinds of catch basin inserts. These are basically devices that go into the inlet vault itself. As you can see in the picture here on the left, this is a kind of a half circle type of outflow screen. But basically this water flows into the catch basin. It uses the catch basin as a capture vault. Water flows through the screen and trash is captured within the catch basin itself and then cleaned out and maintained. At the top, you'll see that there's these bar screens that allow for overflow once the devices themselves get full, and then they overflow into the outflow pipe, which is behind the screen. On the right, you can see some numbers on the percentages on the left-hand side. And that is a system I believe LA is using to understand how full they are because they trigger maintenance devices, or excuse me, maintenance events when they hit a certain capacity. If it's a halfway full in the Bay Area, for example, halfway full or greater full of material. And by the way, about 80 to 90% of the material you see by volume in here is mostly vegetation. That extra 10% to 15% is trash by volume. So it is good at collecting organic material as well. It's just kind of comes with it's the name of the game as organic material is also entering these systems. It's capturing that as well. All that material is cleaned out and then disposed of accordingly. Here's an example of kind of after a few storm events, what type of materials you're seeing collecting, and you can see the levels of trash that you're finding in that example as well. So these are down in the system itself. Use the vault as a capture capture apparatus, if you will. These types of devices are also catch basin inserts, but they're called surface inlet baskets or screens, and they're kind of a different application. Those ones I showed you before really have an application. They may have a grate. When you're walking down the street, you look at a storm drain, you see a surface grate. You might also see an inlet opening that where water is flowing into as well. In these applications, they're mostly associated with surface, like parking lots that have surface grates themselves. They have no inlet opening. And so you can see a basket here where trash is flowing, water flowing into the grate itself. That basket's capturing the material. There's an overflow capacity of this basket as well. And then on the right is an inlet-based design, but you'll have a basket-type system that's also capturing the trash, and then has a screen around the outside of that cylinder that is allowing water to flow through. All of these types of devices have been certified by the state board as meeting the design standards as shown before. So those are really the application of those kinds of systems are at the inlet level. They're generally designed specific for individual inlets, and many of those are manufactured and constructed on site and specific to the inlet. Many inlets and vaults have different dimensions and different sizes of outflow pipes, and are not always uniform, and so that many of them are constructed on site. Some are constructed off-site and then fitted as they are installed. Now I'm going to move into, what I like to say is, you kind of need a backhoe. You need a construction bid to be able to implement these systems. They're quite larger. The one on the left, these are all hydrodynamic separator systems. They kind of come in two different flavors. One is a centrifuging system or a continuous deflection system. On the left, this is a site in San Jose. This is a site that this vault for this system is 40 feet deep from surface. And the diameter, as you can see in the picture on the left with the crane lifting it up, that's the screen for that system. And so we're talking about treating not just an acre or 2 acres based on those inlet-based devices, but now we're talking about treating tens to hundreds to over 1,000 acres at one time. So all that flows through this system. It is centrifuged, heavier sediments drop into that vault. You see the circle on the left. And then floatable materials are screened out as water flows through those screens. These work really well. The ones on the right are kind of the same idea, but instead of doing a circular motion, they're doing a centrifuging on a kind of a vertical profile and settling out material. These are called baffle boxes. This is one in the city of Mountain View that was recently installed, and it's almost as big as a bus. And so these all have to be maintained. And so access, as you can imagine, once they're covered up and is sometimes challenging. And many of them require special equipment to not just a typical Vector truck, but special equipment to and confined space entry to actually get in and clean out. I'll talk about maintenance requirements here in a second. These are called gross solid removal devices, or gizzards for short. They're made by a company called Roscoe Moss, and they originally were developed as part of Caltrans studies back in the early 2000s, and trying to reduce litter as litter controls. They come in a couple different fashions. The one on the left is a tubular or linear radial system, and they have louvers on the outside of these, so you can imagine water flowing through this system. In an inline system, it replaces a pipe in essence, or bypasses a pipe. Water flows out the sides of the louver into the vault and downstream. Trash and sediment and vegetation are captured inside the device and maintained and pulled out through maintenance events. On the right, this is a pump station application in East Palo Alto where you can see the pump station outflows where water flows out and then trash and material is captured behind that little kind of dam zigzag structure on the right, and then that the forebay, or the area where the water's coming out of those flap gates, is where the trash and material are accumulated and then maintained over time. These are all stainless steel louvered panel gizzard systems. And then we have our netting devices. As an example, these are applications where they create a structure, a concrete structure that these are appended to. These are 5mm nets. You'll see at the top on the right there on the application in Livermore that if these get too full and to allow water to pass by, there's an overflow valve on the top that water can come out of. Also, if water flows get too high and above the design standard, they can flow over the crib wall, the wall that's here as well, and to avoid flooding. If they get too full, some of these designs actually cinch the nets, and they come off and they hang on the for maintenance. Most of these nets are disposable. In other words, they're not cleaned out and used again. They are very heavy, and most have to be maintained with a crane because they get full of a lot of wet vegetated material as well as trash. Also very effective in certain installations. Lastly, the third category is what's called by the State Board multi-benefit treatment controls. And those include all 5 of our traditional kind of green infrastructure et al. Facility types that have been implemented for not just trash, but other pollutant removal benefits and hydrologic benefits as well. And they have criteria that you have to achieve to be able to count these green infrastructure systems and multi-benefit treatment controls as meeting the standard for the full capture design as well. And that's all in guidance within the State Board guidance they put out. So as far as installations around the state, I've just kind of estimated here, but given that there's at least 50,000 catch basin inserts that have been installed in the Los Angeles region, and I know of at least 20,000 within the Bay Area, I think it's fair to say that at least 75,000 of installations of these inserts, it's probably a lot higher than that, have been installed to date. And then the high flow capacity systems, San Jose alone has 25 systems plus within their region of hydrodynamic separators and baffle boxes. And I know there's many, many more, not in only public projects, but on private systems as well that have been installed all the way back till the early 2000s. And then there's many, many green infrastructure systems throughout. This is probably a huge underestimate of the number of treatment systems that have been installed on either private or private property or public right-of-ways throughout the state as well. And the way that these are estimated as far as the progress towards addressing the trash amendments is really just tracking the areas that are treated and making sure that they are addressing trash from areas designated as priority land uses or trash generating areas. And so the location, the type, the area that's addressed or treated, and the delineation of that in GIS or other mapping software, as well as the maintenance requirements that come out in these MPDS permits are also part of the documentation that they're achieving the desired goal at the end of the day. You look at the 2 counties that I help quite a bit in Santa Clara and San Mateo County alone. There's been over 30,000 acres that have been treated to date of urban area that's been treated to date in those 2 counties, and that's depicted as the blue areas on the map. And I'm just showing you Palo Alto and San Jose for reference here. And at least and this is a slide that I borrowed from a presentation last fall, and at least 40 million, it's probably closer to 50 million alone within these 2 counties that have been spent just on capital costs to date. And so if you extrapolate that to the entire Bay Area, entire state, we're in the hundreds of millions of dollars that have been spent on a statewide effort just on these trash capture to date. And that doesn't even include all the work that is going to need to be done under the trash amendments by 2030. So we're talking about a huge investment in infrastructure improvements to really as a result of the trash requirements and regulations. The price on these is anywhere depending on what type of device you get and how many acres it treats are estimated here. Maintenance of these really depends on the load of material and the size of the capture vault that you have. For smaller devices, it's anywhere between once a year to 6 times a year. And then for the larger systems, typically once a year, but could be, it's site specific and it could be multiple times a year if necessary. Some of these systems take a day to 2 days to clean. They're so large, these large high flow capacity systems by crews of multiple people. And then obviously the multi-benefit depends. They're all shapes and sizes, so it really varies by system. So that was track 1. Track 2 is basically equivalency. So it's doing anything that you can do or impress upon others to do to try and reduce trash by an equivalent level of what a full capture system would address. So the question then becomes, well, how do we measure that? How do we determine what is equivalent? So the state board has set up a guidance on developing a baseline trash level and then doing some level of assessment or monitoring over time. And that monitoring and assessment methods are determined by proposed by the stormwater permittees themselves, the cities and the counties and the public agencies who are subject to the stormwater permits. And the goal at the end of the day is to determine full capture equivalency. So this gives the option of doing source control work, to do integrate with enhancements to existing actions that are happening. In California, our municipalities run all shapes and sizes. So it could be small, tiny communities that have one commercial area to San Diego, to San Jose or Sacramento, so large urban areas. So having some flexibility on what types of actions and to address the problems that pose themselves with these diversity of urban areas is important, and the state board acknowledged that through the track 2. When you're looking at the types of actions that folks are implementing, they range from true source controls, which are really any control measure that is trying to prevent or reduce the production, distribution, or sale of trash materials that become trash and littered over time. And there are certain types of materials that we find more often than not littered. And I saw Dr. Tom Novotny, who studied this for pretty much his entire career on the call here. Cigarette butts are one of those, where we're really trying to look at opportunities to reduce the use of and the distribution and sale of those materials, as opposed to trying to intercept it, which is what an institutional control measure does, which is really trying to prevent the distribution of that material into the environment, or the leakage of that material into the environment after it's already been produced and sold and distributed, or intercepting it through things like street sweeping or these curb inlet screens, which are up on the streets, so this combination of all these actions is what the goal is, to try to determine the equivalency to a full capture system, which is the other track 1 standard. By the way, in track 2, you can also use full capture systems to a portion of your areas of interest, but it really are in track 2 if you're deciding to use these alternative methods to full capture, and it sets you into a different rubric that you have to then show equivalency through monitoring and assessment. One of the ways to do that that we've helped develop at EOA is on-land visual trash assessments. There are many different methodologies that municipalities and public agencies are trying to use to determine full capture equivalency. One of the methods that is being used in the Bay Area are on-land visual trash assessments, which are basically walking and driving observations and outcome-based observations that are reproducible and practical and somewhat relatively cost-effective monitoring, because they are qualitative visual assessments that are happening. And so we've done a lot of work through state grants and municipal work in the Bay Area to try to validate that these OVTA's methodologies are actually commensurate with the load reduction that we're seeing. And so I'll show you some data on that here in just a second. But they have been used in the Bay Area extensively to try to demonstrate that these other actions are working over time to reduce trash that we're seeing in waterways through stormwater. They can be found, all the protocols and example videos, and can be found at the link here. And it basically comes down to this, is we're trying to get to low, which is basically very little to no trash on the streets and sidewalks available for transport to the waterways through the storm drain system. And there's Baseline that has developed baseline maps in the Bay Area and many other areas, and now in the state have developed maps using these four color coding concepts, and to get a baseline, and then eventually trying to get to a low level based on observations over time. And the foundation of all of this is that somehow these observations relate to the volumes of trash that we're actually observing within the storm drain system itself. And so studies were done in the Bay Area back in the late or early 2009 to 2011 on looking at those levels, and you'll see the outputs here. We see a pretty good relationship between the volumes of trash that we're seeing versus the categories that we're seeing on land, observing on land. And so this relationship has allowed us to have confidence in the results of the OVTAs, that the goal is to get to A, and assuming that is of a full capture system equivalency at that A level or better. To date, there have been about 15 to 20,000 of these assessments done, many street miles walked throughout the Bay Area. From our requirements in the Bay Area stormwater permits, the spatial representativeness that is needed is a minimum of 10% of street miles. And I should say, if you are addressing an area through a full capture system, those areas are taken out of the pool for assessments. They're assumed to be addressed through the full capture system. We're really talking about doing assessments in areas where other types of actions are occurring to generate data to support whether or not those actions, we're seeing the outcomes of those actions on the streets and the sidewalks based on the level of litter that we're seeing. We conduct assessments at 3 times a year in the Bay Area, and we use 2-year rolling averages to report those reductions, and that helps kind of smooth out some of the temporal variability that we see. And so there's 6 events that are used and averaged, and so we work off the averages rather than the best or the worst, and that helps us understand kind of the general central tendencies of this data over time. And then again, in the Bay Area, we get consistently to a low trash generation, which is considered an A score. We're seen to achieve the goal. Lots of questions coming in, and I'll try to get back to these. I'm going to try to get through the presentation first, and then we'll handle this in the Q&A session. When you look at the results, but in the Bay Area, these are the results that EOA has conducted the assessments for. Here's what you see as a breakdown, and the vast majority of sites that we're seeing over time have improved to a green level, and through the actions that have been implemented as a result of the stormwater permit. We do have nearly half of our sites are still at that yellow level, which means they have to need a bit more actions within those areas to try to move into the green. And so that's the kind of the current status, at least in the sites that we've been assessing. But many of these sites were in, you can imagine when they started, none of these greens were here. they were in the yellow and then the red, and then these are all progress assessments after that baseline was developed. And 38% have moved into that green level. So that's a real positive note, and hopefully we're seeing that the levels of trash in these yellows and red areas are also progressing over time. There are some adaptation of this protocol that's happening, and not just through my firm, but through many other efforts. Tablet-based, moving into tablet-based availability, web-based data management systems and visualization portals are being developed for a number of programs and have been developed in the past. It allows real-time calculation of that progress at sites. Then also, we are talking about trying to develop a standardized training platform. We've done 20 trainings so far about statewide. About 750 people have been trained in this protocol and are using it. And then there's lastly, there's a big move right now on many fronts on the use of AI to actually document levels of trash, and kind of using the rubric we've created through the OVTA platform to take photos, many mounted on street sweepers or cars, of streets and sidewalks and the levels of litter that we're seeing, and then using computations to equate that to different scores. So it is interesting how this whole thing has evolved over time and continues to evolve, and I'm sure that's going to be interesting as time goes on. We'll take questions here at the end, so let me just get through the next 3 or 4 slides and we can take some questions. So I want to pull out a couple of control measures where we've actually used OVTA specifically to assess a control measure, and they've had some positive results. And one is, some of you may know that NPDES stormwater permits, many require commercial industrial inspections to make sure that the activities happening at commercial industrial properties are not causing stormwater impacts. And one component of that is trash and litter management, or trash management at those sites. And so one municipality in the Bay Area has actually enhanced that level so that they are specifically looking, in essence, doing an OVTA during those inspections. And what you see in the graph here is in the hundreds of inspections that they did when they went out the first time, and they found, as in the x-axis, you see that the OVTA category on the bottom of the initial inspection, for those that were high OVTA scores, the next time they went out, after they engaged those property owners and made them aware of this, 50% of them actually went down to moderate, and then another 25% went down to low, and some remained at the high level. And if you look at data not here, but if you look at subsequent inspections where they went back again, those high levels actually had decreased to moderate. And the same thing happened with initial moderate sites moving to low. And the good news here is, I mean, it's the engagement of the property owners themselves and the managers of those properties. When municipal staff are going out and engaging those property owners and making them aware and holding them accountable for the trash that is on their business, but not only on their business site itself, but on the sidewalks around their business site, parking lots adjacent to their business site that they own and operate, their customers use. We've seen improvements. So this gives me some hope that maybe this type of control measure, if implemented in other areas, would actually have some results that would be meaningful from a trash reduction standpoint. Now, that said, this is not without cost, for sure. You know, those inspections cost more municipal staff time and resources, and many are already taxed to do what they have to do under the current regime. But it does show that there seems to be some benefit to doing these follow-ups at a more frequent level. The other one I wanted to show you is more of a true source control number. And so I didn't mention this before. We don't just score these sites in OVTAs as A, B, C, D. We're also collecting ancillary data as well. And so for many years, we've been collecting data on how many plastic bags we see up on the streets and the sidewalks, what percentage of the trash that we see is associated with single-use plastic food and food serviceware. that are up there. So we have a big data trove of these very different data points where we can pick and also look to see what kind of change over time we're seeing and what the levels are. And so when we look at what our predicted, we didn't have data prior to a lot of local ordinances that were put in place to ban or prohibit the distribution of single-use plastic grocery bags. But through other studies, we predict that pre-ordinance levels were as you see in that top bar, and then the data we've been able to develop through these ancillary data through the OVTAs is definitely suggesting we're seeing a decrease in the level of plastic bags that we're seeing out in the environment. It seems to be holding pretty steady, at least the data we have here through 18-19. Interestingly, we've been collecting PPE material over the course of COVID as well. I don't have that data to show you today, but that's going to be another interesting component about kind of what proportion of the trash we're seeing is associated with personal protective equipment that we've been using, masks and gloves, and whether we see a decrease in that as we start to pull out of the pandemic will be interesting to see as well. So in summary, a lot of data, a lot of people on this webinar have been collecting a lot of data for trash for many years now, and there's a lot more on collaboration and a lot of work being done on just making sure we're collecting similar types of data with similar types of data standards as well. There has been a pretty and I've done these talks at a national level, and eyes get really big when I start talking about what California has done in the last 10 years, 15 years, because it is, generally speaking, it's very centric to the level of effort is very specific to California. Other states who still have trash and issues and litter issues have not gone this direction, the direction that California has, and have been as progressive on their policies towards trying to address this issue. But I want to point out that most of the work that's been done to date, aside from the cleanups of waterways, has been focused on the stormwater pathway. And so it does, our data that we're collecting does pose the question about how are these other pathways addressed of direct inputs into waterways themselves. And I'm sure that will be a dialogue and discussion that's going to continue to happen over the course of the next few years. The other thing I want to mention is that there's a lot of science being and field testing of protocols that have been done over the course, and a lot more that still needs to continue into the future. But I'm happy we're all this is gaining some momentum, and we're all trying to coordinate, collaborate with each other on a statewide basis to try to best understand what our data mean and how much confidence we can have in it. And then the last thing I want to leave you with is, I think, a super important point, and that is trash capture, interception of trash is a downstream control. Really, at the end of the day, the thing that we need to continue to focus on is trying to reduce the generation of the materials that we're finding in the environment. And there are alternatives to the things we're finding, and this does require behavior change. It requires the help of those who are producing this material, and likely the help of the governments at the state and federal, potentially federal level, to try to help us with this as well. And just as an example of that, on the left, what you see are the types of material that in coastal cleanup days, items that are most frequently encountered, and of course cigarette butts are going to be number one by far. But of all the other things that are here, the vast majority of them are associated with single-use plastic items that are associated with food and beverages. And these are choices that we make collectively to have this material. And as I said, there are a lot of work to try to reduce the use and the distribution and the production of this material. and it kind of is on the periphery of the stormwater component of all of this and gets into policy and legislation. But as you see on the right, the projections, and this is from Science Magazine, is that by 2050, and I think the most alarming thing I've heard is there's going to be more plastic in the ocean by weight than fish by 2050. If we continue to produce plastics and single-use plastics at the levels that are being projected, it's going to be continually harder and harder and harder to treat and intercept our way out of this. So true source controls and trying to deal with these issues at the beginning of the process is what we all, in my opinion, need to be focused on, in addition to the great work that we're trying to do on intercepting this. That interception hopefully is a near-term management option, and a long-term management option is really trying to reduce the amount of material that's coming into the environment that becomes litter and becomes trash at the end of the day. Okay, so I'll stop there. Thank you, Eric. I don't know if we have time for any questions.
What were some of the institutional controls that successfully moved sites into the A category?
Yeah, good question. So we have data now to support curb inlet screens, those screens that are up on the curbs. This is one example of areas that were in the moderate level that they are able to move into the green level from a trash volume generated and transported process. And we're working with Region 2 now to try to fill some data gaps on that and incorporate a performance standard for those curb inlet screens so that they could be applied in areas that have moderate trash generating areas that have street sweeping at least twice a month level. So that's one example. I showed you the example of the commercial industrial areas that had enhanced inspections, more frequency of inspections specifically for trash issues. Those also have shown that we've been able to move those areas over into green just by the more frequent inspections and actions and requirements that municipalities would put upon those property owners to make sure that their areas remain clean over time.
How effective are the OVTA protocols for much smaller items like cigarette butts and vape pods?
Oh, they're good. I mean, we our goal, and it's in the protocol, is really to document, observe anything that gets to the 5 millimeter level or greater that is transportable into the storm drain system. So vape, which we've seen an increase in, tobacco, call them tobacco-related materials. That could be cigarette butts, that could be electronic e-cigarettes, and could also be the packaging associated with all of that as well. And so we see a lot of that out there, and it does form a large portion of what we're seeing. So they do get counted in the OVTA protocol as well.
Next question. How far downstream of a waterway is a FTC allowed to be installed? And follow-up to that is, does the type of waterway matter? Example, beneficial use or non-beneficial use application?
Yeah, that's an interesting discussion. It kind of comes back to what is a MS4, what is a municipal storm drain sewer system, separate sewer system, and what is a receiving water. And so in the Bay Area, we've been ongoing dialogue. It's relatively straightforward if you have a pipe system that is piped everywhere upstream, and you're installing an engineering-based device in that system, and it's covered. There's no open channel. When you get into open channels and that determination of whether or not they're receiving waters themselves, or whether or not they are the place you're trying to install it, even if it's a pipe system, is downstream of a receiving water, that's when the regional water board on a case-by-case basis have to get involved. That's my guidance is at this point. We've had these discussions that hey, it's relatively straightforward when you have an engineered system that's covered up and in a pipe system. But when you get into these open channels or downstream of these open channels, my guidance to you is to engage dialogue with it to your water board before you spend money on implementing those, because they may have some perspectives on whether or not it's allowable under those certain situations. I know that's not a straightforward answer, but at the end of the day, it's going to be a site-specific consideration.
Thank you for providing your insights on that, Chris. The next questions, I'm going to actually combine them from two different people. Caltrans is not a regulating agency, so what can we do about source control? Following that up, are there any guidance or regulations from federal EPA that would require one to do the same type of implementation as these controls, or is it purely just state regulations?
Yeah, so the trash, as many of our regulations in California, the state board has kind of taken a step forward in a much more explicit manner than EPA has. So the direction on the stormwater side of things, and even beyond stormwater, of complying with the trash amendments, is now into state policy and state regulation. So the state itself is the one that is going to be overseeing the implementation and the compliance associated with those regulatory aspects. So EPA is a partner in this, and is supportive, as they've shown through the state amendments and the regional permitting process. But the state is really the driver of this engine. And then on Caltrans side of things, yeah, it's an interesting question. I mean, I think, for Caltrans being a state agency where they can't advocate for legislation or policy development in a way that others might be able to at the local level, I think that, it's trying to continue to be apprised of what's happening at the statewide level, trying to, lend implicit support towards these efforts to try to deal with source control rather than explicitly coming out and supporting source control efforts. I think involvement through, Stormwater Quality Association at the statewide level, or CASCA, and the work that, as true source control is one of the major items in CASCA's vision now, and being a partner in that from an organizational standpoint is also very supportive. But it is a bit more challenging for a state agency to try to figure out how many of the things that we're suggesting are policy implementation actions for true source control that would need to be. And I should mention, on that side of things, there are a lot of bills and a lot of proposed bills that have come up over the last few years that are directly related to true source control. And they're not monikered as water quality necessarily, more on the waste reduction side of things. And those bills, we should be paying attention to those bills because they're super supportive from a stormwater standpoint. The outcomes of them could be very supportive and beneficial to stormwater agencies as well.
Caltrans is conducting enhanced litter removal pilot study and found no correlation between increased effort and OVTA rating. What other FTC measurement methodology would you recommend?
Good question. So I'm not knowing exactly kind of what the outcomes are and how the pilot studies were done. It's a little bit hard to kind of respond to that result or that conclusion. But there are other methodologies that are around that people are using and trying to use volumes as, baseline volumes versus baseline volumes collected or out on the landscape. The challenge with that is requires you to pick up the trash and quantify it at the end of the day, which is one of the reasons the OVTA was created, was to try to reduce the level of that that was necessary. So I'm sure there's others on the call that have come up with their own full capture system equivalency methodologies. and I'm happy to talk to folks from Caltrans, which I have many times in the past, about what they're thinking and what else might be out there. But I'd be interested to know more about the pilot studies and the outcomes of the pilot studies as well.